Here's a problem from Rogowski and Adams Calculus, section 4.4, number 16. The instructions say, determine the interval on which the function is concave up or down and find the points of inflection. So number 16, I've written that problem down. This is y equals x squared minus 7, quantity times e to the x. We're going to have to use the product rule to take the derivative. So y prime is derivative first times the second plus the first times the derivative of the second. And then what we're going to do, probably we ought to consolidate that. So notice e to the x is a factor of everything, so we'll factor it out. There's a 2x times e to the x, and then there's this. I put it in the middle just so that I have this in descending order. Then the second derivative, which is where the concavity comes into play, take the derivative of this. It's 2x plus 2, derivative of the first times the second, plus the first left alone, times the derivative of e to the x, which is conveniently e to the x. Okay, now I'm going to factor out my e to the x, and then gather like terms. So I have an x squared plus 4x. I hope it's okay I do that in one step. 2x times e to the x, 2x times e to the x. 2 times e to the x, negative 7 times e to the x is negative 5 e to the x. Okay, so I'm going to try to figure out where that is positive, that's concave up, negative, that's concave down, and points that it is 0 are places where it changes, so those are potential inflection points. So this term could never be 0, e to the x can never be 0. Hopefully this will factor for me in some sense. Let's see, so x minus x plus 5 and 1. Those multiply to negative 5, add to negative 4. Okay, so where would that be equal to 0? Where are my potential inflection points? X equals 1, x equals negative 5. So let's see. For this being greater than 0, I'd have to be greater than 1. That would make that positive, that positive, that positive. So it's concave up on the interval 1 to infinity. It's also concave up if both of these were negative. So below negative 5, negative infinity up to negative 5, it's also concave up, right? Negative 6, for instance, that's negative, that's negative. Two negatives make a positive. This is always positive. It's going to be concave down from negative 5 to 1. Can you see that if you have a value anywhere in there, this is negative, right? And this is positive, so the whole thing is negative. That means there are inflection points at the two places that it changes from negative to positive, at x equals negative 5 and x equals 1.